Okay, that's better. I don't know what just happened with my screen, but it got weird on my iPad. Okay, simple random sampling is the first way we can take data samples. So remember last class, when we were looking at these observational studies or these designed experiments, we needed some sort of population or sample to actually do our study on. So the question becomes, how do you pick the people you're using in your studies? How do you pick the people you're sending your observational study to? That is what sampling is all about. So this first section is all about what's called simple random sampling, and then section 1.4 is additional sampling methods that are a little bit more complicated than simple random sampling. So first discussion here. Let's suppose a grocery store manager wants to get a feel for how customers view his store. Why would a sample of the first 100 shoppers leaving the grocery store not be representative of the entire population? First of all, what's the population we're trying to study here? Like their customers, yeah. Why would just asking the first 100 people that walk out of your store questions not be representative of the entire population of customers?
Because they're the first people that went in there, so they probably like the store.
Yeah, they're the first people who get there. People who get up and go to the grocery store probably know exactly what's on what shelf and how to get it before they go to work. They're stopping for their coffee or their lunch on their way to their office or whatever their job is. Or they're like people who stay at home on the weekdays or whatever that just are different than just the major population of all types of people. That's a good point. What if you accidentally ask 50 people who are absolutely not morning people? Like just straight up, they're not a morning person. Would they have a good representation of the store if they're in a bad mood because it's the morning? No, probably not. So this, just immediately asking the first 100 people you see is not a good representation of the entire population that we're trying to study. Also, did they even buy anything? What if they walked in, hated everything they saw, and walked out? Then that's not a good representation of the customer in general. So what we get to is the idea of what's called random sampling. Random sampling is the process of using chance or randomness to select individuals from a population to be studied in the sample. For a survey to be reliable, the characteristics of individuals in the sample must be representative of the characteristics of the individuals in the population as a whole. The key to obtaining a sample representative of a population is to let chance or randomness play that role in dictating which individuals are in the sample rather than convenience. What do you think I mean by convenience? Like, why would we not want to use just a convenient sample? Would it represent the whole population? Like if you're trying to see how Mesquite High School students feel about the lunch food, but you only ask the people who sit in the library with their own food that they brought from home, would that be representative of the population? No, but conveniently, you were probably also in the library, not in school lunch, so you would also be very easily able to ask them questions. The problem is, if convenience is used to obtain a sample, then the results of the survey are actually meaningless, because it doesn't actually show you the entire population of people. So what we do is we ensure that we get samples that are simple random samples. A sample size n, so some number, from a population of size capital N, is obtained through simple random sampling if every possible sample size of that smaller letter n has an equally likely chance of occurring. Then that sample is called a simple random sample. Let's see an example of how this works. Let's say Sophia has 4 tickets to a concert. Her and 3 friends are going to go, but 6 of her friends have expressed interest in going to that concert. Sophia decides to randomly select 3 of her 6 friends to attend the concert. It is probability. We're going to get to a bunch of actual probability methods, but when we're doing samples, we have to make sure each option has an equal chance or equal probability of happening. Otherwise, it's not simple random. So we're going to list all possible samples of size 3 from the population of size 6. When an individual is chosen, he or she cannot be chosen again. So to make this easy, here's what we're going to do. Instead of writing the name Yolanda and Michael and Kevin and Marissa and Annie and Katie over and over again, we're going to use the, Kevin and Katie need a letter after their name too. We're going to just use the first letter or first 2 letters of their names to act like they're different entities or different individuals. The first option, a possible sample that I could choose, could be Yolanda, Michael, and Kevin. right? I could pick those 3 people. I could also pick Yolanda, Michael, and Marissa. I could also pick Yolanda, Michael, and Annie, or Yolanda, Michael, and Katie. All of those choices are different, yes?
Yeah.
Great. What's another opportunity for me to choose? What other group of people could I pick? We're going to do this in an organized fashion. Now we're going to choose Yolanda, starting with Kevin and Marissa. Yolanda, Kevin, and Annie. Yolanda, Kevin, and Katie. Then I could pick Yolanda, not Kevin, Marissa and Annie. Yolanda, Marissa, and Katie. And then Yolanda, Andy, and Katie. All of those groups are different, yes? If I had put them in a different order, it would still be the same sample. So far, I have, 10 choices. All of them include Yolanda. Well, what if we don't include Yolanda? What could be some more of the samples? Let's start with Michael this time. Michael, Kevin, Marissa. Michael, Kevin, and Annie. We do have to write all of this out. Michael, Kevin, Katie.
Miss,
Yes.
this is exactly why I hate probability.
We're writing out all of our sample size.
Exactly.
Great. Let's keep going. After Michael, Kevin, and Katie, we could have Michael, Marissa, and Annie, or Michael, Marissa, and Katie. Or we could have Michael, Annie, and Katie. In an organized fashion, what should be the next sample that I choose?
Kevin,
Kevin, Marissa,
Annie,
Annie,
and Katie.
and then Kevin, Marissa, and Katie, and then Kevin, Annie, and Katie. There's one more. What's the last sample I could choose? Marissa, Annie, Katie. Woo-wee!
Hate this.
In total, how many choices for sample of size 3 from a population of 6 people was I able to create? How many is that? Should be 20. 20 different opportunities there. So, commenting on the likelihood of the sample containing Michael, Kevin, and Marissa, which is this sample right here, there are 20 possible samples I could choose. That's not how you spell the word possible. Let me try that again. 20 possible samples of size 3. There's only one of these that is Michael, Kevin, and Marissa, which means that that particular sample, that combination of friends, has a 1 in 20 chance, not change, chance of occurring. But all of them have an equal chance of occurring. They all have a 1 in 20 chance of being the group of friends I pick. Since they all have an equally likely chance of occurring, this is a simple random sample. And that's going to lead us to lunch.
Yes.
That is the first method of finding a simple random sample. The second method for obtaining a simple random sample is by using what's called a table of random numbers, and that is literally what it's called, a table of random numbers.
Okay.
Sounds like I made up that name, but nope, that's straight up what it's called. So here we go. The accounting firm of Sinise and Associates has grown. To make sure their clients are still satisfied with the services they are receiving, the company decides to send a survey out to a simple random sample of 5 of its 30 clients. Imagine doing what we did on the problem before this to choose 5 out of 30. It would take us a long time. So instead, what we can do is the following process. This one's already worked out for you. I'm just going to show you what happened. We took the list of clients and we numbered them from 01 to 30. So they're all the same digits, 01, 02, 03, all the way through 30. Then we looked at the table of random numbers, which I snipped right here for you, that we can use to select individuals in the sample. We pick a starting place in the table by closing our eyes and putting a finger down and a column and a row. Let's say that our finger landed on column 4, row 13. Notice how to read this. This is columns 1 through 5, which means this is 1, 2, 3, 4, 5. Each number is an individual column, not 1, 2, 3, 4, but individually each digit 1, 2, 3, 4. We're going to start column 4, row 13. So take a highlighter right now and I want you to highlight the number 0 right here. That is our starting place that we randomly pointed to on this table. That's column 4, row 13. Just the 0. But because our samples, our population, our data has 2 digits, we selected 2-digit number from the tables using column 4 and 5. So starting at 4, we would choose the numbers 1, because it's 0, 1, and we go down the table. So I'm going to zoom in here to these numbers. They've bolded them for you on your notes. We want to choose 5. How many numbers here are actually bolded? A lot. 1, 2, 3, 4, 5, 6, 7, 8 numbers are bolded, but I only need 5. Why did I have to bold so many if I only needed 5?
Choices.
Well, true, but look at what this says. 52 would be my next number. Is 52 a number in my list? Where does my list go to? 30. So should I choose the number 52? No. So in my head, it's like you're doing this. You're like, never mind, not that one. And then I have 7. Is 7 good?
Yes.
Then I have 44. Is 44 good?
No.
Is 46 good?
No.
Is 37 good?
No.
Is 26 good?
Yes.
Is 11 good?
Yes.
And then we go back up. We go back to the next column. We end up right here. Is 23 good?
Yeah.
Yeah. So that's column, because we just finished column 5, so then we go to column 6, which makes it 23. So our numbers we're using are 1, 7, 26, 11, and 23.
Wait, where's your 23 from?
Great question. See, we ran out of space. We went to the bottom. You go up to the next column at 6.
Oh, okay.
So we have these numbers that we random sampled from our random table of numbers. 1, 7, 26, 11, 23, which means the companies we are sending the survey to are ABC Electric. How do I know this?
Looking at the paper.
Yeah, that's company number 1. What's company number 7? Dino Jump. What's company number 26? Travel Zone. By the way, this is just random. They happen to put these in alphabetical order. That's not necessary, but it's kind of nice. So when you order your companies in your list, you can do it in whatever order because it's also kind of random. They chose alphabetical. 11 is Fox Studios. And then 23, Simplex Forms. So our simple random sample of these 5 companies we're sending the survey to out of the 30 that are working with this law firm, I assume it's a law firm by its title, would be these 5. And we got this from a table of random numbers. Do I need to walk through how you pick the numbers again out of the table? Okay, so theoretically, when you're doing this for actual statistics, you just like randomly put your finger down. You're like, start here. But let's say we happen to put our finger down right here in column 4, row 13. Our first digit is a 0. Since we are using 2 digits to list out all of our companies from 0, 1 to 30, that means I start looking down the list using 4 and 5. So we have 1, 52, but don't want it. 7, no, 26, 11. I finished column 5, I go to column 6, 23. If I was looking for one more, what would be the next number I would use?
17.
And then, would I use 74 in this example? 4. If you happen to get a number twice, like let's say that this number was also 23, because it's random, it could happen. Should you use 23 twice? No, you would just skip to the next one. That's how you use a table of random numbers. That's your second way to get a simple random sample. The third way is using technology. Now, there are a bunch of different sites and programs that you can use to do statistics. Our book offers one called StatCrunch that comes on your online textbook, so we might dip into that when we get online. But we're going to learn most of this stuff with our calculators. So to obtain a simple random sample of 5 clients for the problem in example 2 using our calculator, here's what we do. The first thing you do every single time is called programming the seed. Basically, your calculator has a bunch of lists of random numbers, and you are picking which of those lists to use in general. So every time you do one of these things, you're going to pick a new seed. To pick a new seed, you're going to take the number of the new seed and just type it on the home screen. So for example, let's say our seed is 34. You're going to type just like it says right here on your paper. You're going to type 34. You're going to press the store button. Do you know where the store button is? It says STO. It's right over the on button. It's going to give you that little arrow. You got it? Then to get the random number, which is what rand means, you're going to press math. Toggle over to the menu called probability. And that first option says rand. Press enter. From there, on the home screen, all you have to do is press enter one more time, and it will just return back out to you the number 34. You have set your seed at 34, meaning all of our calculators should give us the same random integer set. Otherwise, you're just going to get a random integer set, which is great in theory, but for class, while we're trying to get our answers to be correct and check our works with each other, we need to use the same seed every time. Once we've set the seed, we actually want to generate the set of random numbers. So you're going to press that math button one more time, go over to the probability screen, and use the last option there called rand int no rep. That stands for random integer no repeats. Random integer no repeats. Type in the values for the lower and upper sets. So in the lower, it would be 0, 1. And in the upper, it would be 30. If we were using the same data set from the question before this. And then the n is the sample size you want. How big of a sample did we want? 5. So put a 5 right there. When you press enter, it should go to the home screen and show you exactly this. You just have to press enter one more time for it to return to you a set of 5 random integers between 0 and 30. Did yours return the same numbers?
Yes.
Fabulous. If those are the companies we're sending it to, instead of using the table of random integers, which companies did this one tell us to send it to? Fox Studios, Casey's Glass House, Precise Plumbing, Walker Insurance, and then Ultimate Electric. Nice. I got lazy towards the end. So what do you notice are important differences in the solutions from examples 2 and 3? And what is the same in examples 2 and 3? Yeah, Fox Studios ended up on both lists. And that's okay because it is a simple random sample. It should be random and each company should have an equal opportunity to get on the list. Sometimes that happens and sometimes that doesn't in the 2 different ways. If you had started with a different seed or you had repeated this process 2 or 3 times before doing the random integer, you would have ended up with a different list of companies. So what does that mean for our descriptive statistics? What does that mean for us when we get simple random samples and we use that information to quantify or qualify different things? What does that mean for us? When we do our statistics, are we always going to get the same values out? Not really, because we're going to sometimes pull samples of different things. So it will likely result in different statistics, in which case it may end up leading to different inferential statistics when we get into the part where we start to infer. So that's why it's very, very important that your samples that you're pulling for your data sets are actually representative of the whole population, because we want to make sure that we're actually using the information that best represents that data to assume things for the whole data set entirely. Now, of course, these are only the first ways that you can get sampling methods. There are other sampling methods that we can choose. Yes?
Why did you use a 34?
That's just random. For my problems, like in your notes, for the most part, I'm going to tell you what to set your seed at, because then we'll make sure we get the same random integers out. Typically, like when you're doing statistics, you just change the seed every time. It doesn't really matter. You can use any number. It doesn't really matter what you choose as long as it's different when you're doing statistics, so that it gives you different integers. I just picked 34 because, I don't know. It's just random, just so we all had the same answer. Otherwise, we would have all gotten different ones. Yes. Yes.